what is functional programming all about? In order to find that out, what we have to do first of all is work out what a function is. So, what is a function? One way of looking at a function is to see it as a black box which takes an input and gives an output. So for example, a function that doubles a number will take in a number like 4, give back a number like 8. Or we'll take in a number like 14 and give back a number like 28. And this is the kind of function that we're familiar with from our school mathematics. It's simply a process that takes some inputs into an output. Another example is multiplication. That takes two inputs and gives us an output. So for example, it takes the numbers 2 and 7 and gives us the output 14. Or it takes numbers 3 and 7 and gives us the output 21. So again, this is a process that takes some inputs and gives us an output. Takes some values in, here the examples are numbers, and gives us a value out, again, a number. And that's it. It's a mathematical function that turns inputs into outputs. So that's what we mean by function when we talk about functional programming. Okay, so that's the first piece of the puzzle. We've answered what is a function. What does it mean to run a functional program? The way that we run a functional program is that we do what we learnt in primary school. We take an expression, something that involves functions that are already defined, and we work out what the result of that expression is. So the first example is something like 2 plus 3 times 4. The way we work that out is we can't do the plus because we don't have an answer to what's on the right hand side. So first of all, we see that that's 2 plus 3 times 4 is 12. And then we can say the overall answer is 14. So what we're doing here is what you might call evaluation, evaluating what this expression is, or we're calculating what the result is. Just like a pocket calculator would do, just like we learnt to do in primary school. So the way that you run a functional program is that you take an expression and you find its value. Let's look at another example. We might look at something like 1 plus 2 times 3 plus 4. Now there are different ways we can evaluate this. We could first of all evaluate 1 plus 2 to 3 and say that's 3 times 3 plus 4. Or we might alternatively say you've got the answer 1 plus 2 times 3 plus 4 is 7. And potentially doing these different things would give us different answers. But no, in fact, what happens is that here we will get 3 times 21, and here we won't get 3 times 21 at all. We get 3 times 7. And here we will indeed get 3 times 7. And both of these will give us the answer 21. So with the sort of functions we're familiar with in mathematics, it doesn't matter the order in which we do the calculation, we'll get to the same answer. And indeed, we can do something rather special here. We could in fact do things in parallel. We could evaluate both sides in parallel. So we could get to 3 times 7 and then get to 21. So one of the nice things that we have in this model of programming is that the order in which we do things doesn't matter. And indeed, we can find here that we can have the opportunity for doing things in parallel. So that tells us we now know what running a functional programming means. Running a functional program means it means evaluating an expression. And then let's get back to the final part of the question. How do we define a function? And the answer here is that we do it like this. We use expressions to define a function. So one way we know how multiplication is defined, we can define the function double. We can say that double of x and input is going to be 2 times x. Sorry, let me clean that up so it just says x. And that is our definition of the double function, because we know that if we want to evaluate double of 2 plus 3, say, what does that work out to be? What does that evaluate to be? Well, by definition, that's 2 times the input, so that's 2 times 2 plus 3. And then we evaluate it just as we evaluated things before, so that's 2 times 5, which evaluates to 10. So the final piece of our puzzle is that we define functions by equations like this. We've said that we say apply double to x, and there's a piece of terminology. When we write something like double next to x, we're saying apply double to x. There. We're saying apply double to x just by putting the two next to each other. That's how we write function application in Haskell. And so when you apply double to x, the answer is 2 times x. And then we work with that just as we would work with any other function, like the built-in functions plus and times and so on. So that concludes what I wanted to say for this particular section. We've now said how we define functions as well as how we evaluate functional programs. We calculate, we evaluate an expression using functions we have defined and get to an answer. And what a function does in this notion of programming, it takes some inputs and gives us an output. So we've learnt the fundamental terminology here is, we've learnt the terminology of function, which has input and an output. We've learnt about the evaluation, or sometimes I'd call it calculation. And we've learnt about definition by writing an equation. And those are the fundamentals that we're going to be building on all the way through. So we build complex Haskell programs, but what underpins those are these simple ideas of what a function is with inputs and outputs, what evaluation and calculation are, what definition is. So that's it in a nutshell.